aspects. We have amazing speakers. We've got John Murtagh, who is head of strategy at Airbus. We've got Ed Parsons, who is a geospatial technologist at Google and a well-known influencer and thought leader in the industry. We've got Barry Nagel, who is a CTO of UP42, and we've got Aravind Ravichandran. Aravind is the head of strategy at Tomorrow.io, but he's also a podcaster. I guess that you will share your links to your podcast, TerraWatch Space, on the chat. Welcome everyone. I'm really super excited. Let's kick things off. So the first question, and this one will be for you, Aravind. The Earth observation is really rapidly developing, and you are talking on your podcast with a lot of different companies and startups. You are also developing your own startup. So what are the new emerging business models that are really driving this this change?
Sure. Thanks very much for having me on, Alex and Muthu. Well, this is really a loaded question to start with, isn't it? It is a really rapidly growing sector. I've been in the sector for the last 6 years, and the way I've understood the sector actually changes every day, every week, based on what you're saying. So, I mean, I think overall, if I were to give big picture, I wrote this in one of my blogs last year, and I don't think that has changed. Maybe that will change as well. But I kind of put it in a stack, and starting with data as a service, which is of course the way the sector has always been, selling Earth observation data, whether it's level 1, level 2, or going down to level 3 and level 4. But if you're looking at just data, obviously, if you were to zoom in on the data part, there are a number of companies working on a number of different types of satellites, of course, space agencies as well. But keeping them aside, just in terms of commercially speaking, different type of companies working on different type of sensors, whether it's hyperspectral, radars, infrared, radio frequency, the type of sensors that's being developed. It's actually pretty crazy. We are starting to put every sort of sensor that we can in space, and also wherever in space possible. We started with GEO, and then we have constellations in LEO, low Earth orbit. And now there are companies that are even working on very low Earth orbit, which is, not 500 kilometers, but more like 300 kilometers. So they are innovating on, propulsion. So, we can get higher resolution data. That's their objective. So that's, a lot of innovations going on in the data as a service part. That's where a lot of, I think, space industry focus is on today. And then if you move up one layer, that's more platform. So platform as a service, that's more for dissemination of data. How are we going to distribute the data? And we have one of the, companies here, UP42, which really helps in, I talked about so many types of data, and, somebody needs to put them all together in one platform and let people access. And, that's kind of what companies like UP42 do, a number of other platforms, that kind of sit in the platform as a service layer. And then above that, you have companies that are focusing on analytics, not just giving the data or making it analysis ready, but then going one level above, helping companies or helping users get analytics. By analytics, it can be, custom data feeds, algorithms, starting with this typical example of number of cars, right? Providing algorithms to count the number of cars or spot buildings, object detection, minimal change detection. That's analytics as a service. And then there are companies that are going one layer deeper, and that's when we enter kind of, is this really Earth observation territory? Because these companies are providing insights as a service. So, these companies can be providing crop identification. That's kind of already becoming Earth observation, kind of blurring the lines into agri-tech. Same thing with property tech, insurance tech, all of these companies taking the data, possibly processing it, and possibly also combining it with other sources of data. So that's insights as a service type of company. So yeah, in terms of business models, it's changing very much, and the line between Earth observation and not Earth observation that's where it starts to blur. But a lot of innovations going on in the sector.
So you've mentioned the role of UP42. So maybe let's bring Barry on. So you guys are actually developing platform that is enabling some of these this new business models. Like how do you find it from your perspective?
Well, ultimately, very interesting, right? As we just heard, I think on the data side, that ecosystem is just very fragmented, right? And it's growing, on a daily basis. There's more and more data being captured on a daily basis. There's a lot of movement in the market, like a lot of new players entering the market, trying to increase kind of the frequency of data captures. And it's getting really hard to kind of find the right data sets. So for us, ultimately, it's really about having this unified and kind of abstracted approach for everyone to kind of be searching across data providers and finding the specific data sets they're interested in, and really bringing this out as a platform for everyone to basically use it.
All right. So maybe a question to Ed, because Google is well known from like bringing this huge disruption. Like we used to pay for navigation, now everyone is using Google Maps for free, right? And this is kind of a standard. So, like, do you see a role of big tech companies in somehow bringing this disruption as well, or changing these business models?
It's funny. I think in many ways, the Earth observation business is like a 50-year-old startup, in that I think around the business models, there's still an element of immaturity, and we're still trying to work out where money can be made, and particularly, where are the real markets that have, commercial sustainability behind them. I think, I like to draw an analogy in some ways, because I'm kind of old enough to do this, back to the 1990s and the original kind of internet boom, where a lot of investment went into what we now see as infrastructure in terms of, internet networks and switches and the capability to build the internet and the web that we all use. A lot of that investment was put in the the late 1990s. There was then obviously the great bust, and many of the companies, the web vans of the world, disappeared, but they left an infrastructure that others could then build on. And I think we're still probably in that stage where much of where we see new business, we see activities happening at the moment, is still probably about building infrastructure. It's about making new satellites, new sensors on those satellites. It's about distributing that data. I think we need to put quite a lot more effort into actually getting that into the hands of customers who will pay for the value, the information that is being produced. It's a bit of a cliche to say that nobody buys pixels, but we're probably still quite in that stage. There are clearly customers that will buy pixels, but we really need to get to the point where we're selling insights that are probably very specialized, very focused on industries, and I don't think we're quite there yet.
So you've mentioned pixels, and one of the things that everyone are talking about in the industry is interpretation of these pixels, or getting insights from this pixels. So the next question is about the role of AI in really making the Earth observation sector more available and more insight generated. So Barry, maybe first I would ask you, like, what is your point on the role of AI?
Sure. So I think AI is playing actually a pretty big role in the Earth observation sector. We've also just heard that pixels versus kind of processing and selling the actual insights and the results is kind of key. But really, if we think about the data ecosystem again, that is ever growing, new constellations, new data sets being captured every day, like how do you actually really start to analyze that data? How do you start to prepare that data so it's analytics ready? Just really looking at the sheer amount of data that is out there and that is getting captured every day. So we actually see AI as, kind of the only solution to really process all of this data, gather the insights, and really support business decisions on this basis. But then also on the AI side, especially, looking at the algorithms, the development of algorithms, it's very difficult, right? It's very tricky to build AI systems. It's tricky to train those systems, especially if you're looking at, a high level of accuracy and quality. So these are also some challenges that kind of evolve around that system. And then ultimately, kind of AI algorithms are, once they're built by specific companies, they're often like also not really shared, right? To be reused by other companies and other users in or outside of the industry. And they're really kind of kept as a private IP. And this is really kind of one of the points why we at UP42, we started to be building this marketplace so that we can really offer processing algorithms, computer vision algorithms, AI algorithms from the leading companies within the industry, so that people can actually reuse these algorithms and include them into their workflows.
Okay, so John, maybe then I will pass it over to you. So, like, what is the approach of Airbus when it comes to the adoption of this different AI algorithms and analytics and so on?
Well, clearly to echo what Barry was saying, increasingly the derivation of derived products from using AI techniques is an increasing part of our business. It helps solve the problem of data overload. One element that we tend to focus on is that within our kind of One Atlas platform, for example, we generally do quite a lot of curating of the algorithms to make sure to stress test them, to make sure that that they do what they say on the tin. So we're constantly evolving the AI algorithms and how they approach, and that's a key challenge that faces us.
Ed, so Google is always thinking like 10 years ahead. So when it comes to different AI and the use of AI in satellite, but maybe also overall in the geospatial space, like what can we expect? And I guess that Ed, you froze for a sec, but now you're back. Hello?
Jen.
Okay, I guess we've lost.
Sorry, Alex,
okay.
My connection dropped. Could you repeat the
so
question?
I wanted to ask about Google and how are you guys planning to use AI for the next decade of different geospatial and Earth observation tasks?
Yeah, I think AI. I think AI is pretty much crucial to any sort of discussion around Earth observation moving forward, just because of the the volumes of data involved. That any sort of sense of having a huge amount of human processing of the data just doesn't make sense. So AI is kind of intrinsic in most of the activities that Google does across the board, including how we make use of imagery. And if you look at Google Maps today, much of the cartography, the road center lines, the building outlines, are the product of using AI methodology on imagery. Some of it satellite imagery, in reality most of it aerial photography, but carrying out sort of basic pattern recognition. And that's what AI at the moment is very good at. It's good at recognizing patterns that we can train the algorithm to recognize. So where we need to do the hard work is that ability to identify patterns, and patterns that are valuable to particular communities of users. So from the cartographic point of view, being able to identify a building is very useful. We can then create a data product and move on. It gets more complex when you start dealing with potentially applications around insurance, or applications to do with the interpretation of multi spectral, multi-domain data sets. It's very easy to clump a lot of data together, identify patterns that emerge, and many of the AI algorithms that we use are a black box, and it's not necessarily easy to understand why features are recognized in the way that they are. So again, I think it's early days, but AI is fundamental, and I guess my main point is that it needs to be AI driven by particular user needs, driven by a particular requirement that we can then replicate and then deploy in a scalable fashion.
If I may add a little bit, Alex, I mean, one of the elements of the business that I'm involved in is we supply a lot of multi-source integration software to support ISR aircraft, such as AWACS for non-US AWACS. And when you've got 20 different kinds of data streaming in from radars, GMTIs, optical, and you have to process the data in near real time to derive actionable intelligence, and obviously we use a lot of those capabilities in our satellite imagery domain, but you really have to leverage advanced AI techniques to meet the requirements to even have a chance.
So I think it actually touches a bit the question that was there from the audience, right? About where the AI is in the value chain. I don't know, Murtagh, maybe you can bring it up. You are on mute. Don't hear you actually. So,
my mute is getting his audio sorted out. I mean, I think there's probably a really fundamental use of AI, which is actually having AI on the platforms themselves and deciding what data is worth collecting, worth transmitting. And maybe one of the ways that we deal with the data volume issues is to actually have more intelligent in-space capability of actually identifying where a change has happened and then telling us that change has happened. Change intelligence is a big part of all of our business.
Yeah, one thing that I want to add here is, I think it was Ed who brought up the point about end user and focusing on the requirements of the end user, right? So I've been in several projects when I was in my consulting role previously, where the fact that we can solve a problem with Earth observation was already great for the customer. So to take an example, we don't have to automate everything with a 90% accuracy. Even if we had to do it only with a 50%, that's great for an end user. And that's kind of what we need to be basing our technology on to solve a problem, right? Instead of being technology driven, which is very, it could be great to work on a problem and get the algorithm to be as accurate as possible, but then for the end user, even just 50% does the job, right? So there needs to be kind of a balance, I guess, and getting to that balance is probably the biggest challenge. I mean, apart from everything we talked about, how do we understand that from the end user, of understanding what would be his sweet spot, right? That's probably going to be the bigger challenge, because he's not going to tell, because he's not, or he or she do not know what is possible. But we then, assume that they need a 90%. We work on a 90%, but then we figure out that 50% was good enough.
So we spoke a lot about the opportunities and challenges related to AI, but maybe John, a question to you, looking a little bit more broadly at the entire EO space. So what are the key opportunities? But then on the other hand, to like go back down to Earth, also what are the challenges and risks that are there ahead of the industry?
Yeah, I do like what Ed said about the 50-year-old startup. I'm going to use that over and over again. I mean, it's very true as well. I mean, the opportunity. I mean, it's we are in a growing business fundamentally, and there's a lot of investment from institutions, governments, but the private sector, and it's a very exciting industry to be involved in, and perhaps in some ways, it clearly varies amongst customer groups. Some customer groups are a lot more mature than others, but the key opportunity is there, to participate in a growing market. Trying to access this long tail of users, people who we know, people who would benefit from using our data and services as part of a wider solution, and but persuading them to kind of overcome this barrier to actually do so. That's quite a challenge. Something that this panel resonated with me, and it's this kind of second. Sorry, excuse me for the disruption there. It's the way in which we collectively, as people in the geospatial profession, how we position ourselves in the value chain, being sensitive to the particular requirements of individual verticals, regions, communities of users. She gave a good example in the agricultural area, but the more downstream you go, the more complex it gets. So it's all about you fail a little better, and then hopefully you crack it. That's the idea. Kind of like pass lessons on from one part of the business to the other. I think one risk, and again, it's risk opportunity is the the two sides of the same coin. There are a lot of assets being released into space, and over 400-500 active EO sensors. In the next 10 years, they predict another 4,000-5,000. The challenge, is how to stand out, how to make sure, and then from a customer's perspective, how that they can make sure, they get the right data. I mean, Aravind said, something very wise, which is, different users have different expectations of quality and different price points, and so how we can kind of balance that in an equitable fashion. Those are the key ones for me.
All right, thanks. So Barry, the life of a startup is just playing in between opportunities and challenges. So how do you see that from your end when we look at the entire industry?
Yeah, very, very similar. I think as a startup in the industry, there is actually quite a few barriers you need to get past in order to be getting started. I think the first one is evolving around like the commercial kind of business and compliance barriers. When you're really looking at trying to get access to data, especially if you look at high resolution data, it's a bit of a different story. And companies like typically run through a very lengthy process that is also very manual in order to be able to overcome the first kind of challenge in order to be able to get access to get started. Then kind of the second challenge for me is more around like the technical part, right? So once you're trying to get access to the data, once you're trying to process the data, there's quite some technical differences in data discovery, data acquisition, and then, as I also already mentioned, the processing algorithms, that they're not really available off the shelf, and you need to invest time into building and training these, even though your expertise might be on a different part of the value chain. So it's pretty hard kind of getting started on these aspects. I think the underlying aspect then is also the infrastructure, right? If you think about what we said about AI and all of the data and really trying to scale and automate these systems, you also need to have an infrastructure that scales and that really supports all of the workloads that you're giving to it. And again, it takes time, it takes knowledge, experience, it's very costly, and it also takes some time for maintenance to be able to operate such a system. So there's quite some barriers really trying to get started. And again, here also the key challenges that we at UP42 are looking at, trying to solve for customers so that they can essentially focus on these core parts that really make up their solution, and that they can focus on their end customer solution.
Okay, so you've mentioned this huge scaled infrastructure, and this is something maybe where we could get some insights from Ed, again using the fact that we've got you here. I'm wondering, like, what is the take of the big tech companies like Google really on using satellite data? We all know, of course, Google Maps in terms of the background data, but I'm thinking about something less obvious. Could you give us some insights how you guys actually make benefit of this data?
That's a great question, Alex. I think benefit is the appropriate term there, because benefit is the value that the user perceives in what you do. And so our focus is very much on different user communities. As you said, most recognizable, ourselves and Apple and Microsoft and everybody else that you can think of in the geospatial platform terms, makes imagery available as contextual background knowledge for people using their maps application on their mobile device, or increasingly navigating in their car, or is part of our everyday use. And it's not a particularly sophisticated use of imagery, but it's one that's very valuable and beneficial. And there's a lot of focus on making sure that imagery is up to date and is maintained and is as fresh as possible. And also is integrated with imagery from, not just from space, but from aerial photography, from terrestrial data capture, and so on. So it provides you with that worldview that is less abstract than cartography and very valuable. That's the kind of the broadest user community. I think it starts to get interesting when you then start to focus on perhaps more discrete user communities that in some ways aren't necessarily best served by the platform providers themselves, but perhaps people that work within partnership of platform providers. So an example might be Google Earth Engine. You've heard that a couple of times already. That's very much focused at the academic and research community in terms of building an infrastructure that you can then use to carry out your research, be that quite sophisticated scientific research, or you're interested in environmental change, or interested in deforestation, for example. You're not necessarily experts in remote sensing, but you're experts in your particular field, but you're still quite technical, and hence you have a web interface where you put a bit of JavaScript and Python into the window, and you do some in many ways quite sophisticated remote sensing analysis, but you don't have to worry about the infrastructure anymore, because the infrastructure is the product. One step beyond that is something like the Environmental Insights Explorer that we've been rolling out. That's very much focused at municipal government and taking Earth observation data, doing a lot of processing, bringing in other environmental data, models, and then telling a local municipality or a policymaker within that municipality, here's the potential for generating solar power. Here's how much carbon your territory is generating every year, and here's what would happen if you made some small modifications. So it's again focusing in all of that knowledge and infrastructure down to a smaller community of users. And I think that's the generic pattern that you will see emerging. You know, a lot of the focus, I think, in the platform providers, ourselves, Amazon, Microsoft, at the moment is about building the infrastructure that allows these follow-on tools and services to be built either by ourselves or probably more likely by partners and people that are currently operating in a garage somewhere with a great idea, but don't need to be rocket scientists anymore. And I think that's where, you know, big tech has its biggest role to play.
All right, so I think that Airbus is also kind of working on enabling this different applications and new models. Could you give us some insights, John, on One Atlas and like what is the aim of the platform?
Well, I mean, if I may, I'd like to speak a little bit broader than that. Look, what we're doing at Airbus is, you know, in common with other businesses, we wish to have a portfolio of products and services which satisfy market demands. So what we're currently actively doing now is deploying our Pleiad Neo constellation, which represents a very significant investment for Airbus. As part of that, clearly we're developing our routes to market. So we're working on DRSs. We're sensitive to the evolutions in the ground segment environment. We're working on the specific. And as part of that, you know, there are platform initiatives that we're working on. We have one which happens to be called One Atlas, which is kind of like acts as a route to market for our data. We can stream the data through robust APIs into other people's services, and it really is focused on our data primarily, but also internally we. You know, we use various, you know, geosolutions, which, you know, where there's a need for, you know, different data sets combining, you know, then we'll use those and internally, you know, we'll derive products and feed them to our customers. So, as I said, we've got a portfolio of routes to market. One Atlas is an element of that. It's focused specifically on our data. So, you know, there are millions of scenes online available, different suites of data, which, you know, elevation data, imagery from the variety of data sets that we offer, and it's constantly evolving.
All right. So, moving ahead, I would like to ask you guys about the competitiveness of the Earth observation space, maybe on a couple of different levels, but from maybe starting from technical perspective, Barry, this would be a question to you. Looking at, you've mentioned the challenge of interoperability of data from different providers. Could you maybe comment a bit on how does it look like from practical standpoint?
Sure. So on that aspect, there's just simply a lot of different mechanisms that, you know, data providers have implemented and that they're offering to the public in terms of you know, data discovery and data access. And essentially then there's also like a lot of different formats that are supported. You know, only if we think about kind of how to manage AOIs, you know, is that like a GeoJSON, a shapefile, or, you know, anything else? There's just so many different standards, different formats and different ways of delivering and managing data sets. So it really can get confusing, and it's also a pretty complex topic. So from our perspective, it's really about kind of the abstraction and unification of interfaces, right? So that we can apply the same discovery mechanisms across different providers to really get that meta information, which then again is going to be very specific, but that's fine for the use case in the end then. So it's really about abstracting it, unifying it, and making this experience as easy as possible for people to kind of work with it. Obviously, then also looking at the data formats, you'd probably also need some supporting functions in order to be converting the formats into formats that you're working with. And I'd say here it's the perfect point again for standards that come into play. If we think about Stack, or if we think about cloud optimized geotiffs, where applicable, and I really believe that this is going to make it easier for people to understand the material and then ultimately to really work with it.
So Barry, are we there yet, or there is like still some work to be done?
I think there's still some work to be done. I mean, we're trying to push hard on this. We really believe in standards and the approach of unification and abstraction. The thing is, for us, we're really looking at all of the data providers that we have in our network, and we're trying to unify it across all of them. So we're constantly at the challenge of, trying to figure out, once we build new features on the platform, how do we actually build something that applies horizontally, to all of the different sources? So it's a bit of a challenge, but we're getting there.
John, you wanted to add something on top. You are on mute.
I think he has to refresh his page.
Yeah, you might.
It happens. I think today, with the number of people in the call, we've kind of crashed the platform.
Yeah, so I guess you can refresh the website and then move over. But maybe Aravind, maybe you've got also something to add here, looking from the perspective of tomorrow AI.
Sure. I think big picture, if I have to put on my tomorrow IO hat, I think big picture, it's important also to appreciate, the inclusion of, weather data into Earth observation. Somehow, it depends on the use case, of course. We talked about starting from the problem and starting from the user need. And a lot of times I've realized that the user need includes weather data. And I know that, for example, UP42, you have access to weather data, and it's there for a reason, because for a lot of the use cases, we talk about agriculture, insurance, whatever market we're looking at, both those data sets go together, and that's the first point, right? Like the inclusion of weather data also into the conversation, into our problem solving methodology. But then the second thing is also, the weather industry is kind of a little advanced then, and there are some best practices that we can learn from from the weather industry. The easiest one being, we don't care about the when we're getting a weather alert or a weather forecast, we have absolutely no idea which satellite was used, whether balloon data was used, was aircraft data was used, none of that. You only get an alert, right? We probably even don't know the names of satellites. I've realized. I conducted a small kind of mini survey among people that I knew in in the community myself, and a lot of people don't even know the name of weather satellite. Although we know we use data from these satellites every day, and 80% of weather models, 80% of data for weather comes from satellites, but none of us not even know the name of a weather satellite, right? So those are things that we can kind of learn from as best practices from the weather world, because with Earth observation, it's probably going to reach the same same situation, because at the end of the day, the value of Earth observation data, not in all cases, but in some cases, is just an alert. We talked about deforestation, or helping power companies manage their their assets. All they get is an alert, right? Like, oh, there's an overgrowth of a tree over this power line, you need to go and cut it, right? That's basically the alert that they need, and they don't care where it comes from. They don't care if satellite data was used, AI was used, or a human was involved in labeling it and finding out that there is a tree. all of them, they don't care. So there are probably some best practices that we need to kind of take into account. And, this is more like big picture. It doesn't depend on if it's satellite or radar or optical, but it's more like big picture. There are some things that we can kind of, learn from the weather world. That's kind of what I've observed in between, looking at both the worlds together.
John, let's try it out. Okay, it works.
Yeah, so I mean, I was just going to say, clearly it's an area where there have been tremendous advances. So the work of OGC and the various NSDI, these national spatial data infrastructures, and GML and such like, they make the kind of the combination of data easier, and for applications such as maritime, in those verticals, it's mandatory you're using multi-source data. But if you're combining data sets, which, for example, the satellite hasn't got a star tracker, so it hasn't got the kind of geolocation accuracy, or if they're using a third-party data set is using a coordinate system where you haven't got all the details of it, it's from a for whatever reason it's different to one that you're using, you can still have these kind of headaches. So I would say that there's definitely an area which there's been great advances, but there's still a lot of work to do. I mean, we spent a lot of time with Pleiad Neo, basically making sure that we're using our own kind of spatial reference frame, so that we can be assured that the data is all kind of analytics ready. But there's a big overhead towards doing that. It's something that you want, that's needed, but it's not always appreciated. But but getting the data co-located, seamless, there's work to be done, but we're a long way down the road.
All right, so going a little bit maybe further, and maybe starting from bringing a question from the audience, and actually the question it was directed to Barry. You've mentioned that access to data is involving heavy compliance obligations. So could you comment a little bit on what you meant by that?
Yeah. So in general, if we're looking at high resolution data, there's quite some compliance and regulatory steps that would need to be executed in order to make sure that the data has been used in the right way, or it's kind of given access to the right people, companies, or institutions. So what we're doing on our side is essentially that we have an automated KYC check. So we're getting the information from the customers, so we can identify the companies and really comply with all of the, well, let's say, legal constraints that are on those data sets, so that we really make sure that we're following all of these regulatory steps. I think maybe John, I guess from an Airbus perspective, you probably would be able to share a bit more on kind of the compliance topics itself.
Well, I'll have a go. I mean, I'll give my points of view, but it's Ed as well. I mean, it's the cloud providers are also in the spotlight a lot on this topic. But I think the point about regulation is that it's always evolving, and responsible operators such as ourselves, have a responsibility to kind of work with the regulations. The governments kind of have a position where, on the one hand, they're introducing a lot of business friendly kind of regulations, encouraging SMEs and such like. The EOSPA's mandate includes elements in terms of encouraging startups and such like. But on the other hand, for totally responsible reasons, there are tools and instruments that states can use, such as shutter control and managing end users, to basically kind of make sure that the data doesn't get into the wrong hands. as Barry said, that's, you know, resolution is often used as a, you know, as a cutoff, and over time, all the precedents are that resolution restrictions are more relaxed over time. But, you know, we're now moving into the area where the commercial sector is producing intelligence-grade data, which can be used for, you know, various defense-related applications, where in the past that wasn't an issue. So regulation is the hot topic. Different countries have very different attitudes towards regulation. You know, in Germany, you know, you have their German data security rules. It's all about the end user. In other countries, it's for resolution. But, you know, I think what Barry just mentioned, this kind of know your customer approach is, you know, it has to be the way ahead. Over time, when regulations become too onerous, and they generally have to they catch up with the technology, you know, you basically, you know, the regulations over time are periodically reviewed. But if I may conclude on the kind of a remark that, you know, it's kind of like the Spider-Man quote, isn't it? You know, with great power, you know, so, you know, we think, you know, we've got, you know, data which is, you know, in the wrong hands can be used, you know, in a, I'm thinking of a word, in a bad way. So, you know, we have to be very careful in that. It can be used irresponsibly, okay? You know, but, you know, there comes great responsibility there, you know, so, you know, we have to, you know, make sure that the data is in the hands of the right people, and that's what regulation's all about, you know. And it's, you know, it's, you know, there's recently the EU has come up with its scheme on terms of, you know, how much responsibility is expected of the cloud providers. So I think that kind of segues into to Ed, I would hope. But, you know, it is a hot topic. We have to take it seriously, and you know, but regulations do evolve over time.
Ed, you were brought, yeah.
Yeah, I don't have much to add to John. I think John's covered the territory very well. I think probably though the focus is going to shift from imagery, which actually, you know, has largely been unregulated. You know, we've had an open skies approach to satellite-based imagery for you know, almost 70 years, I guess. But I think the focus from a regulation point of view is going to come much more in terms of the services and the deliverables that come from the interpretation of imagery, come from decision making that is based on imagery inputs, and there will need to be transparency there to be able to prove and to be able to justify the decisions that you've made based on the interpretation of imagery, which, you know, is aligned, as John hinted at, with you know, new digital services regulation that is emerging in Europe. You need to be able to justify, you know, any decision that you've made based on, you know, algorithmic processing of data. So that will be something that we will just need to bear in mind in, you know. So, you know, if you say a farmer that they're not going to get as much subsidy for their field that they got last year, well, you're going to have to be able to prove, you know, why you've come to that decision based on the imagery that was made available to you. It makes the world a bit more complicated, but you know, I think as John said, you know, with this power comes the responsibility. We need to deal with that.
If I may add one element, I mean, open source intelligence, and what I mean by that is, you know, derivation of, you know, information from publicly available information. You know, we've all seen plastered in our newspapers, you know, the satellite imagery, you know, in the Ukraine, and what an impact it's had, along with other data sets, you know, dash cams and things like that. But that only works as an antidote to fake news if we have confidence that all the way from where the image is taken, you know, processed, you know, disseminated, that, you know, there have been no nefarious activities have taken place. So this regulatory aspect is kind of becoming more and more of a branch of sovereignty, which is just by definition becoming a more important part of our business. As I said, people kind of clam up if you talk about sovereignty, because it implies things like protectionism and the like. But I'm thinking upon it as a kind of an antidote to fake news. And some of the image. I do think the imagery is still an important element of the regulatory environment, Ed. But I do agree that it's widening, of course.
And of course, there's an important point about accessibility and sovereign capability, in that today almost any nation on the planet has the capability of launching their own Earth observation satellites, and that should be something that we celebrate. That ability to look over the fence, I think, as Eisenhower said back in the 50s, is an important strategic capability that should be available to any nation state.
Thanks, Ed, and thanks, John. So now, being conscious of time, I would like to do just one last fire round for everyone, and maybe this would be actually a very good closing set of statements for this entire event. So maybe, Ed, starting with you, how satellite data will improve the world?
Well, I mean, I think it's unarguable that it's doing so already. The use of satellite imagery, as we've already mentioned, for meteorology is saving people's lives every day by having accurate weather forecasting. We have a much better understanding of how the environment is changing in relation to climate change and deforestation. Improvements to agriculture in terms of increased productivity come from the use of satellite imagery. It's already there in, I suppose, relatively established industries. I think where the growth is going to come is in areas where it's perceived to be something that's too difficult or too complex or too abstract, and making that information more accessible to people will develop use cases that we haven't even thought of. But in many ways, the big things that we can do to help society, to help the planet on a whole, we are already doing. We just need to get much better at that. We need to scale up that ability. But without a doubt, satellite data is already improving the world every day.
John?
Yeah, I mean, I really enjoyed listening to the first panel and some of the environmental applications, the monitoring of deforestation, counting trees. We're active in there. It's important. That has a role to play. Increasingly over time, that will become. I would expect it to become more and more sophisticated. I think it was Laurent was talking about all the various ingredients, and Jeff talked about modalities of data. And then we were told that the models were inaccurate for Paris. I mean, I think in terms of improving the state of work, improving those models, handling the data, I think that will will continue to have an increasing impact on how we all exist, and in parallel, this advent of open source intelligence as an antidote to fake news, I think, is also an important trend as well.
Barry?
Yes. So I think adding to what Ed has already said, for me, it's all about kind of the educational piece, kind of the material that we're putting out there, the use cases, kind of sessions like these today, where we're really looking at the long tail as well, right? Being able to bring this geospatial technology into a broader audience that has a different perspective, different background, is really going to be key in driving the adoption, but then also the innovation. And again, what Ed said, I can just 100% agree. We'll probably see use cases and solutions that we have never thought of before.
Thanks. And Aravind, over to you.
Right, I think they've all covered most of the points, but I think if I have to summarize, I think the answer would be, I don't know, right? Because we can talk about ways that we know today how satellite data is being used, But in the future, I think the way forward is going to be how satellite data together with other sources of data is going to help in different use cases, things that we have not thought about, especially if it reaches the hands of people who have not used it before outside our community, right? Like we've only talked about, folks who are expert in remote sensing, geospatial, and who know work with the data today. But then once it reaches the hands of people outside and they understand how to work with that data, that's when I think a lot of these unexploited potential will be realized. And we are collecting more data than we have ever collected before in the history of humanity. So it's going to be good.
I certainly agree with that comment. There is an interesting comment from Jeff on the chat. The biggest impact will be where we don't even consider EO as part of the solution, right? So this is probably indeed a very good closing statement actually for the panel and for the entire event. Thank you guys so much for taking your time and discussing with us and with the community.